With the new TCC 78000, massive investments are being made in heavy handling in the port of Rostock in Germany. With a height of 164 meters and a load capacity of 1,600 tons, this crane today shapes the skyline of the Rostock port. When building this giant, an LTM 11209.1 from Megalift and an LG 1750 from Mammut were used in tandem operation to lift the mast tip at a height of approximately 100 meters. Not an easy job to achieve during a light breeze on the quay edge.
Damit herzlich willkommen in Ehingen.
Now, welcome to Ehingen. I'm standing here at our mobile crane approval area and on an LTM 1750 9.1. But this one is not a standard 750-tonner. It has the new 800-ton upgrade. This upgrade results in a massive payload increase. Consisting of a new boom configuration with the use of a V3 lattice boom piece and a recalculation of the crane's more than 70,000 payload charts, the LTM 1750 9.1 now has an 800-ton load chart and additional tables for 3 different wind speeds. Especially for the erection of wind turbines with the typical 80, 90 or 100 meter towers, the 800-ton upgrade increases the load capacity, depending on the radius, by up to 55%. Due to this upgrade, the crane absolutely meets the new requirements in the wind industry with even higher and heavier systems. And as usual, every existing LTM 1750 9.1 can be retrofitted with this 800-ton upgrade. Just speak to your Liebherr partner.
When we say
that this LTM 1750 9.1 has been completely recalculated, what does that actually mean? Well, among other things, the finite element method, Vframe, is used here. But what's behind this technical term? First of all, it's an extremely important method. Without it, an extreme lightweight construction, as we use it in crane construction, would not be possible. The question is always, how strongly is the material subjected to external forces? The pressure of a geometrically simple shape, such as this spare parts box, can easily be calculated using known physical formulas. Every push results in a pressure that is mathematically calculated. But how do you calculate more complex shapes for which there are no calculation formulas, such as the slewing platform of our crane here? Now the finite element method comes into play. The body that has to be calculated, in this case the slewing platform, is broken down into a finite number of sub-bodies with a simple shape, for example, into many of these small spare part boxes. These are the finite elements. The physical behavior of each of these small elements can be described by mathematical equations. With the help of many small bodies, complicated shapes can be calculated. The result of these equations means for us, the more stress, the redder the color in this area. When calculating the payload of our cranes, we are of course dealing with a large number of small elements, and therefore with millions of equations. The more elements, the more accurate the result. With this method, we have the possibility to evaluate many different construction ideas without having to physically build them.
Ohne dass wir sie physisch bauen müssen.
The requirements to have cranes lifting heavier loads is nothing new. The fact that cranes come to the site at all requires similar technical efforts as the increases in lifting capacity. However, this is not about the question of whether they get there, but what happens on the way.
Sondern was unterwegs passiert.
Diesel scandal, CO2 emissions, climate protection. These keywords have long been familiar to all of us. But what does that mean for our mobile cranes? Emission regulations for on- and off-road certifications are handled differently in many countries and are something to ask the expert. I brought in our engine expert, Daniel, for this. Daniel, you recently performed a complex test series to demonstrate how clean a diesel engine in a mobile crane really is. What exactly are the requirements for mobile cranes?
In contrast to trucks, mobile cranes are subject to the off-road standard, both on-road and on construction sites. Modern mobile cranes, with the single engine concept, only have one engine that covers road travel and construction site operation. all diesel engines from year of construction 2019, which are installed in mobile cranes and are approved in EU countries as well as in Switzerland and Norway, must comply with exhaust emission level 5.
Der Stufe 5 entsprechen. Das passende Pendant dazu
The requirements are similarly high as the on-road standard Euro 6C.
And what exactly was measured, tested and compared?
In the past few months, we have carried out extensive PEMS tests and brought in experts from TÜV Nord and IAV. In real operation, without the special conditions of the laboratory tests, just on a standardized route typical for driving, which in addition to city traffic also includes overland driving and the motorway, we have compared the emissions of the loaded 44-ton Mercedes Actros truck with a 60-ton Liebherr crane LTM 1160 5.2. The engineers from TÜV Nord and the specialists from IAV, who are extremely experienced in PEMS measurements, were there all the time. We chose the route together based on the official specifications of the legislator and performed 2 sets of measurements. The first one to ensure the truck and the mobile crane are within the Euro 6C, and the second one to compare one to the other.
And what are the results?
Our Liebherr cranes with emission level 5 are able to meet the requirements of the Euro 6C standard. Both the nitrogen dioxide and the carbon monoxides emitted by the crane were in the same range compared to the truck, and the hydrocarbons were even below those of the truck. The LTM 1160 5.2 would therefore clearly be suitable for the certification of the Euro 6C standard. This is the clear statement of the specialists from TÜV Nord.
We're delighted that the real drive emissions of our mobile cranes meet the highest comparable truck standards and don't have to hide behind modern long-haul trucks. This shows us that we're on the right way, using the latest engine and transmission technology despite the short travel distances of our mobile cranes. A mobile crane has to meet the correct emission standard depending on the country. However, technology is key, not only for the crane engine, but also for the payload of the crane. The more lifting capacity, the bigger the crane. That's easy to understand, and exactly what we're going to look at now in Moudon, Switzerland, with an LR 11000 crawler crane. With the adjustable Vframe, which many of you already know from the LR 1800 1.0 presented at the Bauma, an LR 11000 has now been equipped in Switzerland. The big advantage, the ballast can be changed incredibly quickly, thanks to the V-frame in the radius and even with vario tray in the actual weight. This saves you from having to re-stack the ballast or move the entire crane. An absolute bonus, especially on cramped construction sites, such as this one in Switzerland. Long before the job was started, Michael Egger, managing director of the crane rental company Egger, approached us with his requirements for a more flexible derrick system. With the customer, we were able to develop this V-frame solution for the LR 11000. And now it's been used successfully.
Without this V-frame, we would have needed much more time for this. And combining the ideas of Liebherr with our own resulted in being able here today to present a fantastic outcome to our customer.
The dismantling or erection of bridges using cranes is a common sight. But what cranes and ocean liners have in common, and how a crane goes hand in hand with footballers in famous stadiums around the world, will be shown in the next issue of Upload magazine. Until then, you're welcome to take part in our Spot the Crane Challenge. A brand new mobile crane will soon be leaving our plant here in Ehingen. And I can tell you, it is striking. If you see this crane, take a picture and post it on our Facebook page or on Instagram. More information will follow soon via our social media channels. Have fun, take care, and goodbye.